Hello, it's me again, and we're back for episode 3 of my repair pile. This is my repair pile. I think this is season 3 or something. I should start calling them seasons actually, so that we know where we are. So I repaired 2 Commodore 64s in the last one. Well, I've diagnosed them to the point where I'm happy to replace the chips later on, but they are, for all intents and purposes, repaired. And I've got 2 more on the bench here, and I've already numbered these 3 and 4. So let's crack on with number 3. I've already removed the screws from both of these cases and had a quick peek inside. And this one has all broken case clips. These 2 screw posts are intact, but this one is broken off and is actually still here in the corner of the base. And what I was thinking I would do is actually leave that there. The screw is still in here holding it in place. I'll leave that there and try and glue it, put some epoxy resin on here and put the case back on and see if I can push against the screw from the other side, and maybe it will fix this one. Maybe that's a good idea. I don't know. We'll see. The more I talk about it, the less I think it's a good idea. Something that's good on this one is there are 2 CIAs in sockets. In fact, everything, all of the major chips are in sockets, all of the ROMs and CPU, PLA and the CIAs. That's all of them. And that's going to make fixing this one or diagnosing it a lot easier. The other thing is that if these CIAs are working, we can put these in machine number 1 to see if that is fully fixed. It's really dirty and dusty. I'm just going to give it a brush off. I just noticed as I was brushing it that the heat sinks come loose on the voltage regulator on the 5 volt 7805 regulator. So I'm just going to tighten that up. There we go. Let's plug it in. Oh, that seems a bit like maybe a CIA, possibly gone bad. So we've got good output from Des test, and there is a bad chip, which is bit 1. Right. So with bit 1, look at the RAM error code flash chart. RAM error flash code chart. That's a terrible title. This is for the dead test. So it gives you the flash codes and which chip that they correspond to, but it also shows you the data bit on here. So if we know it's bit 1, it's U9. They don't really make much sense, and it's not something I can ever remember. So U9 is bad on this one. I'll point the thermal camera at that in a second. But the other thing I want to do is try normal diagnostics and see if that makes any difference. Oh yeah, it tried. Oh, U9 and U11. Is that going to give me the same 2 in a row? It does. Let's give dead test a try as well. 1, 2, 3, 4, 5, 6, 7. U9. So that agrees. But I'm interested in why the diagnostics shows 9 and 11. So we've got U11 is here and U9 is 2 along. So these 2 are the ones that are suspect. This one is definitely suspect. So let's point the thermal camera at it and see if that gives us any clues. No, the RAM looks perfectly normal. I'm tempted to whip U9 out and see if that is the problem. Let's do that. Okay, hot air is set to 330 degrees and 90% airflow. So I've got my amazing Retro Chip Tester Pro as well, but for little jobs like this, I just plug this in. It's just a bit more convenient. Yeah, dead chip. Oh, it's not quite in the socket. No, it's still a dead chip. Just test the replacement chip before I put it in. Yep. Right. Capture, we have Des Test Max ready to go. Yep, good. CIAs are counting up exactly the same. Let's try it with full diagnostics. No, full diagnostics. Because Des Test only checks the first 4K of memory, so we need to run the full diagnostics to check the rest of the memory, and then I need to test the check with the test harness to test everything else. When you see me test these, I often speed these up, so this isn't, I've probably cut some of this out. Oh, you'll be able to hear the SID now, and let me know if it's working. I'll check in the edit. I'll actually check these on my bench screen so that I can hear the SID. I need some way of monitoring this. I'll have to figure out how to do that. So one thing I do before I do the full diagnostic is give the edge connector a clean with an eraser, or as us Brits like to call them, a rubber. That just gets rid of the surface grime. It doesn't do too much. It will eventually wear away, you know, even an eraser will wear away the gold contacts, but just to get the surface grime off is fine. The other thing I like to do is spray the inside of my connector here, because this one always struggles. I'll do that one as well with some contact cleaner, because it has a lubricating effect as well. It just makes it a little bit easier to get onto that one, and I really have struggled with that in the past until I started doing that. Serial port, keyboard, control ports. I've put it on no RAM check because I've already checked the RAM, it was fine. And everything's good. So I've got two working CIAs here, albeit very, very dirty. Look at that. They are minging. So I'll pop those out, and at the end I'll probably take these out of here and put them in the other one. But yeah, one bad RAM chip, that's all. Not the most exciting repair, but it's nice to see the diagnostics picking it up and giving us the correct diagnosis. So full diag pass U9 bad. Need to check the keyboard, but that's the only thing that was wrong with it. I will put that aside. So this will need some case work because the case clips are all broken on it. There's that broken post as well, and these two broken posts from the bottom that can all be glued back. And I'll actually, once the case clips are done, which is my least favourite job, I do not like fixing case clips. They never go quite right. Once that's done, tested the keyboard, so Paul can clean it, and that'll be done. So machine number 4. This one also has all of the chips socketed, and this is a 250425. That was a 250427. No, 407. This is the later board, which is got the cost reduced clock circuit in it, slightly different chip layout. Anyway, so we've got again 2 CIAs, slightly less grubby, in sockets, ROMs in sockets, CPU in sockets, SID in a socket, and PLA in a socket. BIC obviously in a socket, and this 8701 is in a socket usually as well. Fuse looks like it's intact. Let's give it some juice and see what happens. Actually, before I do that, let's take the screws out. The post come away there. But this one has got case clips. Yeah, it's got the old thinner case clips, but they're intact. Right, let's go without any diagnostics first and see what we get. A black screen. We go for Des Test Max first. Nothing. Oh. It's very dead. We've got power because the LED's lighting on the Des Test Max, so we've got voltage in there. Let's have a look. Actually, the first thing I'm gonna do is look at it with this, because if there's something immediately, what? That SID is at 150 degrees. I'm going to say the SID is bad. It's lighting up like the sun. Yeah, that's really, really hot. Oh, sorry, it's not the SID, it's the PLA. The PLA has lit up like the sun. It's so hot I don't actually want to touch it because I can easily burn my fingers because I've got such poor heat sensation in my fingertips. Around the edges should be okay, but yeah, that's down to 50 degrees now. Right, so let's get a PLA to put in there. I've got this Gal PLA. I don't know if it's going to go in this socket actually, is it? Yes, it does. Marvellous. Right, now that's not going to explode. Well, we still don't have an output. Okay, so the thing to do is actually start popping out chips. Right, so let's have a quick look at it with thermal camera before I start pulling chips out. And the CIAs look fairly normal temperature. There's this ROM here is a bit warmer than the others, so that's a good indicator. The CPU is not too bad. The SID is a bit warm. That's not warm at all. 12 volt regulator is a bit warm. And the VIC2 is not too bad, 42 degrees. And the RAM looks okay, but these multiplexers next to it are warming up more than I'd like, and they are MOS branded, which is not a good sign. That is never a good sign. Right, taking out the first CIA, not that. Let's try the next one. Let's capture. Nope. I think it was this ROM that was looking hot, wasn't it? I can't remember now. Oh. Yep. Still not that one. We're running out of options here, but I think it's those multiplexers for the RAM. There's too many MOS chips on here. There's no MT RAM, so the RAM is probably okay. These chips are all probably okay. Yeah. Let's get the SID out just in case. So I just took the SID out, and one of the legs was bent over the side. I don't think that would have caused it to crash though. Test it again. No, The first things to check while it's running still is the clock. Oops, on pin 39. Yep, nice clock. Signal there. And reset. So it should stay low and then go high. Perfect reset. All right, I haven't got the pin out for the multiplexers with me, but I'm just going to scope them and see if there's any horrible looking. That doesn't look very good either. Oh. Yeah, quite a lot of those look bad. I think I'm just going to take those out and see what happens. Just going to protect this resistor array next to it. So I've got my stunt board here, and this has got those multiplexers socketed, so I can easily test if these are working or not. It's a black screen. So that one, I will just verify that the test bed is working. If I can get the chip out again. Quite has wedged itself right in there. Not the best sockets, these. So I've put the good one back in. Right, and this is why you should test, because I've got no PLA. I've put my PLA in this one. So that works. Let's pop this chip out and put the other one back in. Oh, it works. All right, we'll take the other one out. Will it work? No. Oh, ah. Bad guess. One thing I haven't checked is the CPU, so let's check that. This time I will take the suspect and put it into a good machine. Not very long legs on that one. Nice long legs on this one. CPU is good. Okay, I've put those in sockets because they are MOS chips, but they are working, so I'm not replacing them. That's because these aren't my machines. I probably would replace them if this was my own Commodore 64. Yeah, I'd probably replace it. Let's put the processor back in. Let's give the socket a wash. And just try it once more. Nothing. Right, so what I'm going to do. Right, so what I'm going to do with this one is I'm going to put its chips with it. Take this PLA replacement out for now, and I will come back to this one off camera and do some investigation, see if I can narrow down what the problem might be, and then I'll come back to it in maybe a full video, or maybe an extra add-on video to the repair pile. Depends how interesting it is. If it's really interesting, it will make a proper video. But that's as far as I want to take this one. I'm going to put this away and we'll go on to the next one. No, that's both these machines. So that's this repair pile video done for now. Sorry that it wasn't a satisfactory conclusion, but the idea of these is just to basically triage, and if it's a simple repair, to repair it. And it looked like it might be a simple repair, but it's not. So if it's complicated repair, not what these videos are for. Thanks for watching. I'll see you in the next one. There will be lots more. Hope.